Hi, everybody. This is a pre-recording of online week 10 for Dr. B's AP chemistry classes at Guilford High School. Today is May 26th, and we're going to go over your plan for the week and talk about the results of the survey that we did last week. I do have a bunch of videos here. I don't want to spend too much time on them, but these are back when we did the iodine clock reaction. If the audio actually works, and I hope it does, I think one thing you might notice is there's just a cacophony of sound back when we used to have classes in, real classrooms. So let's click on any one of these randomly.
They're saying the more that we have, the longer we did the
Yeah, so I said
Oh, okay, yeah, like 10 times.
Okay, we're done.
Woo!
15.
You ready? We're rolling.
I think even Ben's team is going to come.
That'll be fun. And our faces are
Stir. Okay.
literally like it looks like I'm in heaven, like the blur.
Not bad. Not bad, but it didn't.
Okay. I think you get the idea. Let's try to go forward here. Stir. Wow. Okay, here's the plan for the rest of the school year. We're now into week 10. We'll be looking at the survey results, and you'll be preparing a recorded screencast, which I'll go over on the next slide. The following week, week 11, we will be performing reflective essays on other people's presentations. And for the last week, it's unscheduled at this point. School does end on the 10th, so it's just, I guess, a few days. We'll do something, I think, that brings us back all together. Boy, I would love to get some sort of a group photo if we could manage that. Graduation is on May 17th. I'm going to show this slide again at the end, but there's so much survey data, I don't want to get lost in it. So for everybody, here's your assignment. Here, I'll just read it from here. Create a 5-minute recorded presentation on a chemistry-related topic on either hydroxychloroquine, which I'll call H, or remdesivir, which I'll call R. And here's some topics you can choose, but you can also choose a new topic, your choice. I'm going to show you a 5-minute video that I did to give you an idea what we're looking for. So I'll let you read all these details once we go online. First come, first serve. Pick any one of these for your presentation. It's only 5 minutes. I do suggest using Screencast-O-Matic. There's a free version of it, and that's how I'm recording this one. I will show you an alternative method, and boy, it didn't work that well, so there you go. So that's what your assignment will be, due on Friday at 9 a.m. sharp. 50 points. Okay, we're going to go over the survey results actually now. I'm going to do this super briefly. It's amazing how once the test is over, you don't really care so much about the details anymore. So I'm going to gloss over much of the stuff that is just administrative in nature and only go over the things that I think are relevant moving forward. Okay, we did 2 surveys. The first one was should we do for the last few weeks? Now that's relevant. And so here's what you guys said. How do you feel after finishing it? Just about everything. Should we do nothing for 3 weeks? A teacher should never ask that question. Your answer was over 43% said, yeah, let's do nothing at all. Let's see. Should you do your own research project? It's a little bit of everything in terms of responses, but I would say not super popular and hard to do when we can't do wet work. We watched movies last year and did things on them. That definitely was popular. And by the way, if you want to revolt and say we really hate the idea of the topic we're doing and you want to try to switch over to this, we can negotiate, we can talk about it. So if you feel strongly about this, you'll have your chance to say your piece. Let's see. One slide summaries of each major topic. Boy, that would be useful. And that was surprisingly fairly popular. It would help me so much for next year. So I'm planning on staying away from it for now. But if you want, tell me you want to do that one. Okay, let's see. Ideas that since the new official AP Chemistry, oh yeah, the official AP Chemistry videos, we didn't use them much, but now that they're out, we're hearing they're very good, so we could do a project on that, but not too popular. Let's see, one slide summaries. Another idea is get a science-based movie. I think I already did that. Interview people for your career. Great idea. Not all that popular. Here were your individual responses, including I want to build a distillery at home. Please don't do that. I want to do experiments at home. All of that is strictly forbidden. No experiments at home, period. Okay, so those are all the other ideas people came up with. But after having looked at everything, I decided I think we should just do these 5-minute videos since they're so timely and it's a very rich topic that people might find interesting. Okay, let's see. Responses to the shortened at home. This is about the exam. Did you take it? Yes. Did you take it, and were there any issues? We had about 10% submission issues. Nobody is contacting me regarding the fact that they can't get it resolved, so I'm assuming everything is okay. How hard was it? Yeah, it's an interesting result, right? You guys said about 7 on a scale of 1 to 10. Did you have problems uploading answers? Boy, I asked a lot of questions about this. It was last week the topic of the day. I don't really feel like I care that much anymore. We did okay. If you had issues, see me. They're not going to do a test like this next year anyhow, so I think I was responding to the message boards on AP Chemistry, which everybody was like just red hot angry about this. So there you go. Should we have spent more time reviewing other topics? Now that's very important. Looking at the test, I did see a large segment of wavelength questions, and we never did a Beer's Law lab. I feel bad about that. We didn't spend too much time talking about wavelength, energy, things like that. We did cover it, but wow, they really focused on that. And I'll be honest, I'm a little worried about that. Next year, we have to make sure we do more wavelength type labs using these things called Spec 20s. But here's some of the comments that we had. A lot of you said you were fine, which makes me feel pretty good. It is a strong class. It is a crazy year. How things happen when they post on July 15th. That's when you get your test scores, July 15th. We'll see what happens. I'm still predicting high scores overall. Another thing is that today, they promised they would post the free response question behind the audit wall, meaning I'll get it, and maybe they'll say, please don't share it. I have no idea. I checked it about 15 minutes ago, nothing yet. Other questions about the strategy we used, and here's all your individual responses. You can pause this and read it, but I think our strategy overall was fine. Let's see. Could you have cheated? Boy, here's all your individual responses. Feel free to read it. I don't think it was a big issue. Cheating. How'd you choose to answer your questions? Most did by hand and uploaded them. This may be interesting, I don't know, for AP to review, but look at this, all the different formats people use to answer it. All sorts of tablets, laptops, smartphones, the works. Did you do the demo test? Thankfully, about 90% of us did, and maybe that's why we didn't have too much problem uploading. 72% of you thought there were too many questions on the exam. In hindsight, I bet they did that on purpose to try to prevent cheating. You're so busy just answering the questions, you don't have time to go to some weird site or to afterwards like bring in some expert into your room and say, quick, take a look at those answers, that kind of thing. So hopefully that wasn't a big issue. Your setup, please give me comments. All sorts of people gave lots of comments on the setup. I'm surprisingly disinterested in this now. I hope that doesn't bother you. Did it cover most of the topics? Some people said yes, some people said no. I have to say I'm a little concerned that they did focus on some pretty specific topics, not necessarily my favorite ones that we would have really blasted on. And there's answers on that. Let's see. If you watch those videos, were they any good? And basically about half of you said you did, half of you said you did not. Those who did and put in the time, not surprisingly, said they're very good. I do think they're very good, and I plan on incorporating them into next year's regimen. Let's see. Other ways you could have cheated. You could read those comments there. And here's some timely information. They're supposed to post the free response questions and their answers today. I'm really looking forward to seeing what that is. I do think we should go over that next week. You take a look at the details that I have posted there, including an email they sent to me. Okay, so this is the exact same slide that you saw earlier. This is the assignment for week 10, and here it is. Choose either hydroxychloroquine, which you'll note only has one chiral center there, meaning a position where you have a carbon, that's generally what it is, with 4 different substituents. And here you have the amine here, you have this whole alkyl group here, you have a methyl group here, and implied is a hydrogen. 4 different substituents. This is a stereocenter. This methyl group could either be coming out of the board, that would be one stereoisomer, or going into the board, that would be the other. And remdesivir, by comparison, has 6, count 'em, 6 chiral centers. It's not a pill. It's something you have to inject, and very different drug. So pick one of these topics. For instance, you could say, I'm going to talk about hydroxychloroquine and new drugs that are in the pipeline that have nothing to do with either of these. I guess that doesn't, yeah, new alternatives to remdesivir treatments. Talk about the history, money issues. If you're sick of doing chemistry, I will allow somebody who wants to go into politics about it, things like that. That could be fun to hear. And everybody pick a slide. Here's mine. I think I will take the time to show the whole 5-minute presentation. So first, I made a little slideshow talking about how hard it is to make remdesivir large scale. I did include my sources, and that's it. And then I presented it, and it took 5 minutes. I'm going to play this YouTube video. I really hope that the sound comes out when I do this. Otherwise, just fast forward past it. It's about 6 minutes long. I might make it go a little faster if that works. Hey, Dr. B here, and in this 5-minute video, we're going to go over why it's so challenging to synthesize remdesivir on a large scale. A couple things about it. You've probably heard of it. It is the only FDA-approved drug worldwide for the treatment of the coronavirus, which has been a worldwide phenomenon. It's not a pill. It's an injectable. And its structure is shown right here, structure 4B. It's about a molecular weight of 300 or less, I would guess, which means it could be a pill, but it's not. And why that's the case probably has something to do with its metabolism. Maybe the liver perturbs it, something like that. In any event, it's also a prodrug, which is interesting, meaning that this whole part here is cleaved, rendering it with the active part of the molecule here in your bloodstream. So what you take is not what is actually active. And after that phosphonate ester is cleaved, you end up with this thing, which looks a lot like adenosine, but it's not. It's a little bit tweaked. And so when the virus uptakes adenosine, it uptakes some remdesivir instead. And suffice it to say that gums up the works, renders it inactive, and that concept has been proven in large-scale trials. I don't think that's in doubt. So we do have a way to actually attack this thing, and it's known that it works. How well it works, I'll let other people talk about it. I want to focus on the synthesis. Here it is shown here. And it really doesn't start from the beginning, since it begins with these 2 substances here and here, which you'd have to synthesize, but you could also just purchase them. So let's imagine you do on a massive scale. You probably would need, I don't know, tens of tons, hundreds of tons, thousands of tons in order to do this on a worldwide scale. I'll have more to say on that in a minute. But these steps are not easy. This first step, for example, uses N-butyllithium, which is a very moisture and air sensitive substance. It usually is purchased as a solution in tetrahydrofuran. You also need trimethylsilyl-chloride, very reactive species. That combines these 2 things. You then add on, you deprotect it here. See all those benzyl groups? That means a benzene ring with a CH2 group on it. They all get removed. We then add on part E here, which is the whole phosphonate ester. And then you have to fix up the fact that you've got all sorts of chiral centers that have to be right. There's 6 chiral centers in this molecule. That means 3-dimensionally specific regions. You usually just look for the wedges and the hatches there. So once you start it, with these 3 chiral centers already intact, and by the way, they have to be not only relatively correct, meaning up, down, down, but also absolutely right, meaning that you don't have the non-superimposable mirror image of this substance. So once you have that right, you then do this step called chiral HPLC, which cleans up and removes some of the stereoisomers, which any medicinal chemist can tell you is very challenging since they're so chemically and physically similar to the actual structures, but now you isolate the individual stereoisomer, and you then get 4B, you have to remove 4C, and then you have the final product there. The yields are lousy if you take each yield and multiply them by each other. So you're going to get 60% of the 25% yield that you had after 2 steps, and then 58% of that after 3 steps. So I think you can see if you multiply these all together, you see that you're below a 1% overall yield. That's tough. That means you have to start with at least 100 times of the amounts that you need in order to get what you need at the end, right? So you're going to lose over 99% of what you start with. The 3-dimensional nature of it is also challenging. So these HPLC separations work fine on the benchtop, doing anything that involves a column. And this is high-performance liquid chromatography, meaning things run through a column or a pipe. When you have to scale those up, the costs go up dramatically, and the challenges do too. Now, the current supply, according to Gilead, is that they have Currently, they say enough for 140,000 courses. Now, this information is a little bit dated. They've probably doled that out already. That's not just 140,000 injections. That's 140,000 courses, each of which consists of a 10-day worth of injections. What will they need? Well, a lot. They've estimated several million, which is a round number, but I think you can imagine that if there's a worldwide need, and there is, the numbers of courses will certainly be in the millions, so they are ramping things up. Can they do it? Well, Gilead and the companies that they're collaborating with have extensive experience in this. For an example, this is Tamiflu, which is used for the flu, not for the coronavirus, but for the flu, and I've taken this drug myself. I found it to be very effective. And Gilead, in conjunction with other companies to help them out, made 200 million courses of this. So yeah, they're experienced making large-scale supplies. My major source for all of this information was a presentation by Julia Gangemi. Thank you for that, Julia. And I also took a good look at a Chemical and Engineering News article. If you want to take a look at it, there's the link there. This is a little bit about the challenges of synthesizing remdesivir on a large scale. Okay, good. Let's see if I can get past this here. I did the same thing. I'm not going to play this, but I thought it might be easier for you guys just to take your cell phone, point it at a screen, and record it that way, or maybe even just have your screen on while you record it with your smartphone. You can still try that if you want, but I actually did it, and it didn't work out as easily as I thought. The big thing that caused a problem was that after I created it, it was a 554 megabyte video. Now, that might be due to my smartphone and its high resolution, but I had to upload that thing manually, and it's like that's just so slow and so much information. So I really recommend a screencasting program such as Screencast-O-Matic, which I think is awesome. But if you want to do it this way, do it. Go for it if you want. I'm not going to play that. And then next week I'll be posting each of your wonderful topics, and I can't wait to see them. Okay, that is AP Chemistry, Week 10. Everything's available on Classroom, so if you have any questions at all, please contact me.